Thank you for joining. Today we're going to go over the results of the vulnerability testing we ran on the data trust systems. We conducted a series of vulnerability testing on the targeted system outlined per requirements. This included network scanning techniques, vulnerability testing, and ethical hacking. We used both active and passive methods for testing. We found that in the network system, there was poor server security hardening and a lack of firewall or any other network filtering controls surrounding the server. The ethical hacking identified that we had far too many ports open on the noted server, and we were using far too much outdated software with known vulnerabilities. Finally, we did penetration testing of the web application that was found to be on the server. This had a number of exploitable flaws, including critical findings that exposed a backdoor vulnerability to the system. There were a total of 3 critical, 2 high, 4 moderate, and 4 low findings. This covers the whole spectrum of risk. We'll talk about the network system for a little bit next. The testing and the evaluation of the network was done with a combination of techniques. This included passive inspection using Wireshark. We looked at the network traffic flowing on the network. And then we used active scanning methods such as port scanning with other tools to inspect the actual host itself. We found that there was one single subnet network, 10.0.2.0, with a single server host on it being the .7 address. There were various applications in place on this host. We placed a single client within the host, a Kali workstation, that was used to run the active and passive scanning. We also found that this particular server had far too many services and ports open on it and lacked any security controls that surrounded it. The main concern we have with the network security, specifically on the server host, is that there's too many things happening at once. There's too many ports open. It's best practice to separate services and have them each housed on their own server within their own security zone to reduce the attack surface area. But in this particular case, the host had 27 services listening on the same host. This brings a whole series of risks into play here, specifically around both integrity and security. By having so many services open, you're reducing the security of the individual services and the data on the server by means of allowing many attack vectors. The compromise of one particular piece of software might gate someone root access to the server, therefore giving them access to the data for all the other services. We're recommending strongly here that this server be completely rebuilt. It's going to be good for data trust to adopt NIST's guidelines for firewall policy and firewall setup. This will specifically allow data trust to do a better job of zoning and putting firewalls around the server. We're also recommending that data trust adopt the NIST security hardening guidelines. Happy to take any questions you have about the network security or what we've just spoken about. Let's go over the ethical hacking and vulnerability testing we carried out on the system we found. We carried out ethical hacking and testing of the target system using several tools. This included reconnaissance tools and port scanning tools such as Nmap and Ncat. The primary tool we used to carry out the testing was a combination of Python and Nmap. We used the Python Nmap script to interrogate all the open ports on the server and determine which services were running, and also tell us which versions of the softwares that were available. The script found 27 services to be found on the server. These included many versions of software that had a whole variety of vulnerabilities associated with them. One of these particular vulnerabilities was an older SFTP service called Very Secure FTP daemon. This particular version had a known flaw which allowed a backdoor to be opened up and root access gained on the server itself. Unfortunately, this one is classed as a critical bug and poses a significant threat to data trust. The main outcome of our vulnerability testing of the server itself is that we found it's old, it's dated. There's simply too much that's out of date. Since there are 27 ports open running varying different services on them, each one has software that backs the service. For example, the Very Secure FTP daemon I noted. Also OpenSSH, Postfix, and a variety of others. Each one of these particular versions of service are either past end of life and not receiving security support anymore, or they have known security flaws that could be leveraged now that are well documented and published on the website. Not only that, but the actual server itself was running Ubuntu 8.04. This version of Ubuntu is old. The current version is version 24. This is now end of life. Now, because of so many of these services being outdated, this server should be shut down. We're at an extremely high risk to data trust as a result. We need to look at replacing this entire server. Not only bringing the software up to date, but the operating system itself. The best avenue that we're going to have to do for doing this is building a new server to replace it. Also, we found that having this outdated server with all these outdated services is in direct violation of the data trust security policy. The security policy says that we have to have meaningful patch management and bring all software up to date. We failed to do so here. It's our recommendation that we replace the server and also look at adopting NIST's guidelines for enterprise patch management. This particular guideline is going to help us do a better job of maintaining up-to-date software on all of our systems and put in place a regime for patch management to prevent this from happening again. I'd be happy to take any questions you have now about the server vulnerabilities or the patch management noted previously. We found that the server was also running a web application, so now we're going to talk a little bit about the web application penetration testing that was carried out on it. During the discovery and reconnaissance phases of the testing at the network level, we found that the server had port 80 open and there was a web server listening on it. We found when inspecting this and visiting it that it was actually the DVWA application. We used a variety of tools to conduct scanning and analysis of this web application. These consisted mostly of OWASP's ZAP as a proxy and a vulnerability assessment tool, Burp Suite, which also acted as a proxy and allowed us to apply some intruder payloads to the website to try and leverage some suspected flaws, and finally SQL Map. Since we found that the website was backed by a database, we then leveraged SQL Map to try and interrogate the database and reverse engineer its structure and pull information out of it. This was an important one as we were able to pull password information out of it. We have all the findings for all of these vulnerabilities documented in the penetration testing report. Unfortunately, we found too many flaws in the web application. The DVWA application had too many risks. It appears that this website was not written with security best practice in mind, and we were able to exploit quite a number of flaws in it. That includes a cross-site scripting flaw, both stored and reflected, SQL injection flaw, an insecure direct object reference flaw, and it had poor session management. For the poor session management, we noted that there's no device fingerprinting and it was susceptible to session fixation. The session ID did not change upon login or logout. Unfortunately, each one of these flaws is pretty common, but it's also very avoidable. In Data Trust's web application security policy, it outlines that we're supposed to be following the OWASP testing guidelines. Now, had these guidelines been followed during the testing of this application, we would have found these flaws and we would have prevented them. At the moment, we're recommending that this website be taken offline. There are critical flaws in there that make it very important we take it down. We're at a great deal of risk right now. In addition to that, we want all of these flaws repaired using the cheat sheets that are provided by OWASP for each one of these flaw categories. And then we want our security application policy to be updated to do a better job of adopting the OWASP standards. I'd like us to look at the application security verification standard and look at adopting it into data trust policies to follow it. Please let me know if you have any questions about any of the vulnerabilities found in the DVWA web application. I'd be happy to answer those. I'd like to spend a bit of time talking about the OWASP outcomes, specifically their top 10 and the application security verification standard. The OWASP top 10 is a series of documented vulnerabilities that occur quite often. They're common in web applications all over the world. The OWASP has collected information about what the most common vulnerabilities are through consulting with the industry and collecting information and running statistics. These are the most common. Now, as it happens, the vulnerabilities we found in the DVWA application fall into these top 10. The OWASP publishes guidance on how to understand each one of these vulnerabilities, how to prevent it, and they've written up detailed cheat sheets on how to carry out doing design and development to protect against these. We need to adopt these. Data Trust needs to incorporate the top 10 as part of its methodologies for application design and development and testing. We're part of the way there by having already nominated the OWASP testing guidelines for doing testing. Now we need to fill the gap and go the rest of the way and bring it all the way back to the design and development phase to bear these in mind. This top 10 represents a solid foundation to start protecting our web applications against vulnerabilities. The OWASP Application Security Verification Standard is the next evolution of the top 10. It looks at an entirely holistic approach to the architecting a software application for security, protection, and self-resilience. It covers everything from software design through to self-logging, through to protection, through to self-reporting and alerting. It is a very comprehensive guide that touches on all aspects of application design. Data Trust, we should be adopting this standard for all of our web application development. Once we've used the cheat sheets in the OWASP top 10 to address the immediate risks, those 4 risks raised earlier, we should then go back and look at road mapping the next major version of the DVWA application, specifically to re-architect it following this standard. This would improve our resilience to an exceptional level compared to the industry. Our security controls, specifically our policy for web applications, does not make any mention of this standard. It only mentions the testing guide. After we include update our policy to include the top 10 and roadmap this one, at that point in time, we should also be including and mandating the ASVS as part of our development strategy in our own policy. This presentation has covered the findings in general. We've only given us a small high-level summary of these and identified how many there are. The risk is critical. These server and these applications need to be taken down, re-engineered, and repaired. The actual report that has accompanied this presentation has a very detailed summary of all vulnerabilities found. If you flow down to the end of the report, there's a summary table at the end called Risks and Mitigation. I've clearly identified every risk that has been found, nominated the CVE number for all of them, and made a specific recommendation of how they can be repaired. I've also included copies of the OWASP cheat sheets and the ASVS and updated other materials from NIST to support our repair and mitigation processes. If you have any further questions, I'd be happy to take them now. I appreciate the time you've taken to allow me to present the results. I look forward to working with our engineers and our testers to make repairs to our systems. Data Trust, go Data Trust, we love Data Trust.